Hello again, Mr. Wakefield here, and we are at our very last video of the semester, that last video lecture, and it is going to be work problems. What exactly does that mean? It is referring to when two or more people, or it could be machines, two or more machines, working together, all right? What happens in that case? How do we handle that when two or more people are working together, or machines? What we use is we use this formula right here, which I abbreviated like I usually do. Rate of work times the time that was actually worked is equal to the fractional part of the job done. So if two people are doing the same job together in order to save time, for example, this is the kind of formula that you can look at. Okay, now, the rate of work is a fraction. It's always a fraction. That's what this line is right here. That's a fraction bar. Okay, so for example, let's say that you are able to paint a house, a particular house, in 5 hours by yourself. The alone time, meaning by yourself, that's how long it'll take you. Okay, so if you can paint a particular house in 5 hours, then that means that your rate of work, the R, is going to be 1/5. It's not 5, you guys. Very important. It's 1 over whatever your alone time is. So, for example, if your friend is slower than you and they can paint the house in 7 hours, then that means that their fraction for the R would be 1/7. If I can do it in 9 hours by myself, that means my fraction would be 1/9. Okay? So what you do with that fraction is you multiply by the actual amount of time that was worked. Okay, remember, this is just saying if you painted the whole house by yourself, this would be the amount of time on the bottom here. It would take you 5 hours. But this is the actual amount of time that was worked. Remember, we're working together here with somebody else. And so just because you can get the thing done in 5 hours by yourself does not mean that you're going to need to work for 5 hours because you're getting help from somebody else. So this is the actual time worked. Let's say, for example, this is not an actual problem we're going to do, but this is going to help us understand the problems. Let's say that you actually worked 3 hours. Okay. So what is FP? It's the fractional part of the job done. Okay. Think about this for a second, you guys. If your rate of work is 1/5, and let me explain something about that here first. 1/5 is the amount of the house you could get done in 1 hour. So if your rate of work is, if the amount of time it takes you to paint the house alone is 5 hours, then your rate of work is 1/5. That means that that's the amount of the house that you can get done in 1 hour. Okay, so you can get 1/5 of the house done in the first hour. You can get 1/5 of the house done in the second hour. You could get 1/5 of the house done in the third hour. Okay, if you can get 1/5 done in each of the first 3 hours, okay, wouldn't that be equal to 3/5? 1/5 plus 1/5 plus 1/5 is 3/5. But a shortcut to figuring out that the answer is 3/5 is to multiply by 3. Same thing as 3 over 1. If you multiply the fractions together, don't you get 3/5? Okay, so that's how the formula works. This is the 1 divided by the alone time. But it's also known as the fractional amount of the house you could get done in 1 hour. 1 hour. All right. Or if the unit of measurement in the problem is in minutes instead of hours, this would be the amount that you can get done in 1 minute. All right. But usually they measure in hours in these problems. Usually. And then, again, this is the actual time worked. You multiply it together, this gives you the fractional part of the job done. So that means that after 3 hours, you could get 3/5 of the house done. Okay. Now, I'm going to revisit this formula here as we go along. Let's jump right into the first problem, though, and then we will take a look at that again. Edwin can tune up his Chevy in 2 hours working alone. Okay, again, that means that his R number is going to be 1/2, right? Because remember, it's 1 divided by your time working alone. Okay, we'll get to that in a minute. Bo can do it in 3 hours, again, working alone. So that means that Bo, his R number is going to be 1/3. How long would it take them if they work together? Now remember, you guys, that's just one question there, isn't it? They just said, how long will it take working together? They didn't say how long would it take for each of them individually. Okay, it's just one question. The time working together. The time that it takes to get it done working together. So there's 3 different kinds of time in one of these work problems where 2 people are working together. It's the alone time for the first person, which we already know is 2 hours. It's the alone time for the second person, which we already know is 3 hours. And then you have the time working together, which is the question. Now, a lot of people look at that and say, hey, can't I just take the average of 2 and 3? Can't I just take the number right in the middle, which would be 2.5? No. You cannot, okay? Here's why that doesn't make sense. Okay, Edwin is the faster one, right? Because he can do it in 2 and Bo can do it in 3. Isn't it true that if Edwin can do it by himself in 2 hours, then if Bo is helping him, even though Bo's a little slower, isn't it true that the 2 of them together should get it done in less than 2 hours then? Because if Edwin can do it all by himself in 2 hours, then if he's getting help, they should be able to get it done in less than 2, right? So the together time, you guys, is always going to be less than the 2 alone times, which in this case is 2 and 3. It's always going to be less. The together time is always going to be the smallest of the 3 times because they're working together. All right, so it'll never be the average of the 2 alone times because then it wouldn't be the smallest number. It would be in between the 2 alone times, and that can't make sense. The together time has to be the smallest of the 3 times. Okay, just like the motion problems, you guys, we're only going to have 2 rows here. Okay, I know that they're working together, but there's just not any information that we're going to need there for the together, okay, like we did in the mixture problems and the interest problems. Okay, you'll see that here as we go along. We won't need that. So for work and for motion problems, you don't need a 3rd row. And so therefore you can't add down on the 1st and the 3rd column because there's not a 3rd box to add it to or to make it equal to, okay? There's just 2 rows. So what are the 2 rows? The 2 rows are the 2 people that are working together. Edwin in this case and Bo, all right? Again, there's no 3rd row. Okay, what is the rate of work again? Since it's always going to be 1 divided by the alone time. So for Edwin, it's 1 divided by 2, because 2 hours working alone, like we said. Bo is 1/3 because his alone time is 3. Now here's the thing about the time actually worked, okay? We're always going to put the together time in there. And it's not going to be a 1 on top of it either. It's just going to be the together time. Okay, so the together time always goes in this second row. I'm sorry, second column. Okay, this is always going to be 1 divided by the alone time, as we already talked about. But this is always going to be the together time. All right? Now, we already know the time working together. It's T. Okay, so actually both of these boxes are going to be T. These 2 boxes are always going to be the same. It doesn't mean that they're always going to be a variable, but they will always be the same thing, though, whatever it is, whether it's a variable or a number. And the reason why that's true is because the 2 people working together are always going to start at the same time, and they're always going to keep working until the whole job is done. And so their together time is always going to be the same for both because they start at the same time, and then they'll both stop at the same time when the job's done. And so that's why these 2 boxes have to be the same. But it's going to be equal to T in this case because this says time working together. So it's the together time here. Now, we don't know anything about the fractional part of the job done here. They don't tell us anything about that. We already used up our variable on the together time, which belongs in the second column, as you know. And so, like usual, if we can't fill in a box in the 3rd column, what do? We use the formula to go across. What's 1/2 times T? Well, remember, T is the same thing as T over 1. And so 1/2 times T, 1 is the same thing as this. And so that's going to be going, multiplying the tops and the bottoms. That's going to be T over 2, isn't it? And so in the same way, this is going to be t over 3, isn't it? Because it's 1/3 times t over 1. So we have, let me just make that a little bit more clear here. We have t over 2 and t over 3. Now, we only need one equation, right? Because we only have one variable. So what is it? Okay, here's how it works. Let's go back to that formula I showed you earlier, or that example I showed you earlier, and this will help you understand the equation. If you can paint the house in 5 hours working by yourself, and you've been working for 3 hours, you just completed 3/5 of the job, didn't you? Let's say now that you suddenly stop. This isn't normally going to happen, but again, this will help you understand the formula better, and it'll help you understand the problem we're doing better, even though it's a little bit of a different example. Let's say you suddenly stop when you get 3/5 of the house done. How much does the other person that's helping you have to get done in order for the whole job to be done? Well, if you did 3/5 of the house, wouldn't your friend have to do 2/5? 3/5 and 2/5. Why is it that 2/5 is the right answer there? It's because 3/5 and 2/5, 3/5 of the house and 2/5 of the house, since these are common denominators, I can add these two fractions together and we get 5/5, don't we? Which is equal to 1. Why is it important that it has to equal 1? And it is important that it does have to equal 1. It's because the two of them together, and that's why we're adding, the two of them together are getting one whole job completed. They're getting the one entire job completed. And so it has to add up to 1. The two fractions have to add up to 1. Okay, so if your FP number is 3/5, then your friend's FP number has to be 2/5 because it has to add up to 1. Anyway, my point is this, you guys. When we go back to this problem, in the same way, these two FP fractions have to add up to 1 also. Okay, whether they have a variable in them or not, they have to add up to 1 because the two people are working together to get one entire job done. And so that's what we're going to be doing in these work problems in this worksheet. Okay, you fill in your boxes. All the boxes need to be filled in. We don't have a third row and a second column, so none of them are going to be blank. Fill in all your boxes. You've got your last two boxes here in the last column, and they'll always add up to 1, and that's where you're going to get your equation from. And you're always going to need only one equation in these problems too. And so once you get that equation where it adds up to 1 in the last column, you're fine. You just have to solve it now. Okay, so these are a little bit shorter problems than a lot of our other word problems, with that, at least amongst the box problems anyway. How do I solve that? Remember, you guys, that when we have a fraction equation, in most cases that we've seen in the past, you have to do that LCD thing where you multiply both sides by the LCD. Isn't it true here that for 2 and 3, the denominators, isn't it true that the LCD is 6? Because that would be the lowest common multiple. Okay, for the multiples for 3 would be 3, 6, 9, 12, and so on. For 2, it would be 2, 4, 6, 8, 10. The smallest one that's common to both is 6. And so what we do is we multiply both sides of the equation by that LCD. And we learned back in the fraction equation section, okay, when we are learning how to do fraction equations, we learned that you multiply both sides by the LCD by doing the following here. If you have two fractions being either added or subtracted together on one side, and that's all you have on that side, you then multiply both of them separately by the LCD, and then the plus or minus that's in between the fractions just comes on down in between that. And then if you have just a normal number on one side of the equal sign, not even a fraction at all, you just multiply that by the LCD, 6 times 1. Then you got to figure out what these three things are equal to, okay? The three things you multiply by the LCD, and then you'll have a normal looking equation you can solve after that. And when we did the fraction equations, when we had these three different parts here, what we did was we multiplied, again, each part together, each of the three parts that I circled. That means to cancel first if you can. Since everything's just a single term in our numerators and denominators, you don't have to do any factoring first, thankfully. But this should get rid of the fractions. 6 and 2 reduced down to 3 and 1, so we get 3 times t is equal to 3t. 1 times 1 on the bottom, that means the fraction is gone, right? When it's 1 times 1 on the bottom, because that's equal to 1. And you don't need to write the fraction when the bottom is 1. Okay. Bring down that plus. Same thing here, the 6 and the 3 cancel. Okay, and we get 2 times t is 2t, right? With 1's on the bottom. Don't need to write that. Bring down the equal sign. And then 6 times 1 is 6. So now I have a normal looking equation. We're almost there. Now I solve that equation. Combine like terms. This is just a normal linear equation. Divide out. And we get t equal to 6/5. Now what I want to clarify here, let's write this down here at the top. And this is going to be true for all 3 problems in this worksheet. Write your answers in the form of a mixed number. I'll remind you how to make a mixed number here if you don't remember that. Okay, so what you're going to get in each one of these answers is you're going to get a fraction answer. Put it in lowest terms like normal. But it's a lot easier to go up to somebody and say a mixed number instead of a fraction when you're talking about this. Let me show you what I mean. Okay, how long, that's referring to time, right? How do they measure time in this problem? They measure it in hours, right? Not minutes. It'd be kind of weird if you went up to somebody and said, oh, the 2 of us can get the car tuned up in 6/5 hours. Because then the other person's going to say, 6/5 hours? That sounds kind of strange. I don't know what that means. Because you usually don't talk about time in terms of fractions, do you? Usually you talk about it in decimals, like you might say 1.5 hours or 1.7 hours. Or you might say a mixed number. Okay, it makes it a little bit easier to understand. So, sometimes probably the most common way to do it would be to say like 1 hour and 10 minutes or something like that. I'm not saying that's the answer here. I'm just not going to require you to do that. Okay, you don't have to do that. That can be done, but you don't need to do that. But the next best way to do it, other than to do 1 hour and 10 minutes or something like that, is to make it into a mixed number. So that's fine. How do you do a mixed number? You divide the top by the bottom, like this. Make sure to put the bottom on the outside. How many times does 5 go into 6? 1 time. 1 times 5 is 5. The remainder is 1. And so that means that it's going to be 1 and 1/5. Okay? So what's already up there is the whole number part of the mixed number. And then the remainder and the outside number right here, that forms the fraction. Make sure the outside number's on the bottom. Okay, just like it was originally down here. And you end up getting 1 1/5. Again, 1 and 1/5 what? Since it's time that we were trying to find, time worked together, and since the time is measured in hours in this problem, then that means it's 1 and 1/5 hours. And there you go. So that's how we do one of these work problems. Now this next problem, which is on the second page, it's going to be a little bit different as far as where the variable is located, but otherwise very similar. Let's take a look. So the second page, let me zoom out a little bit here. Actually, we don't need to zoom out. We're fine. Albert can paint the front of his house, speaking of house painting, in 8 hours. Working together with his wife Betty, they can paint the front of the house in 5. How long would it take Betty to paint the house if she worked by herself? See how the question is different here? Okay, in the last question it said, how long would it take together if they worked together? All right, this time it says, how long would it take Betty to do the house by herself? So I'll call it T again, but this time it's, remember we got 3 different types of time in these work problems, don't we? Okay. We have the time for Albert working by himself. We already know that that's 8 hours. It says Albert can paint the front of his house in 8 hours. Okay, notice it didn't say Albert with help from his wife. No, it said Albert painting in 8 hours. That means that that's his alone time, isn't it? So his R number is going to be 1/8. We'll get to that in a minute. Working together with his wife Betty, they can paint the front of the house in 5 hours. So the 5 then is going to go in that middle column. Remember I said the together time goes in the middle column. Okay, but it's the Betty's alone time, that's going to be our variable. Time for Betty to paint by herself. Okay. Let's set up those boxes again. Again, work problems, 2 rows only. We always have the 3 columns because our formulas always have the 3 parts in these box problems. Since this is a problem where 2 people are working together, again, that's when you use this formula, like that. And then the 2 rows are represented by the 2 people working together, Albert and Betty. Now, here's where it gets a little bit tricky. Not the first box, but the second box. The first box, as I mentioned just a moment ago, that's 1/8. Because Albert's alone time is 8 hours. That means that his R number is 1/8. Now, here's where people a lot of times get tripped up. Listen carefully here. A lot of people think, oh, hey, time for Betty working by herself, that goes here, and so I just put T here, right? No. Remember, the R box is always 1 divided by the alone time. So if the variable represents the alone time for Betty, we don't put T in here, but we put 1 divided by T. Remember, the alone time goes on the bottom. The 1 is always on top. So you can't just say T here. It's got to be a fraction where the alone time's underneath and the 1 is always on top. Okay, so be careful not to fall for just putting T in there. I know, yes, T does go in there, but it's not just T only. You got to have the 1 on top of the thing that represents the alone time, which is T. Okay. Now, as I mentioned a few minutes ago, as we know from the last problem, the together time always goes in the middle column, and the 2 boxes are always the same. Since they told us that the together time, the amount of time it takes them to work together, is 5 hours, that means that this is going to be 5 and 5. Now, once again, we don't know anything about the fractional part of the job getting done by either person. We don't have a variable for that, and the variable is for Betty working by herself. And so the only choice we have is to multiply across. 1/8 times 5 over 1, okay, is going to be 5/8, isn't it? If you multiply those together. And in a similar way, 1 over T times 5 over 1 is going to be 5 over T, like that. And what did we say in the last problem about once we fill in all these boxes? We take the last column, that's all you need. Just take the last column and you say that they add up to 1. And so that creates an equation with your variable in it. And that's all you need is just one equation with your variable in it, because we only have one variable that we're doing in this problem. Okay? Now that I have my equation that I need, I solve it. And I solve it by, since this is a fraction equation, we need the LCD. I know that there's some problems where we didn't need the LCD when we did fraction equations. For example, if you just had a single fraction on each side and you were able to cross multiply, that's different. Okay. But this is not one of those types, okay? Usually, let's put it this way, as we learned back in that big fraction equation section we did prior to the last test, if you have one of those problems where you got 2 fractions on one side of the equal sign with a plus or minus in between it, then yeah, you're definitely going to need to do the LCD. And that's what you're going to see here in this section, in this worksheet on all these problems anyway. So if you got a fraction plus a fraction, you're definitely going to need the LCD. What would the LCD be in this problem? Well, without going through an entire review of how to find the LCD, just remember that if you've got just a constant denominator like 8, no variable, and then the other denominator is just a variable, it's not like 2t or 3t, it's just t, then whenever you have two denominators, one of them just a constant and one of them just a variable, the LCD is always going to be just those two things together, 8 times t. Every single time. Just so long as those are the only two denominators. Okay, it's a nice, easy way to just figure out the LCD. But just in that case. But you do see that in a few of these problems, though. A few of these work problems. Where one of the denominators is a constant and one of them is just a variable. Just like in the last problem, you guys, we are going to, again, when we have two fractions being added together, we multiply them both by the LCD, and we just bring down the plus in between. And then when the other side is just a one term and no fraction or anything on the other side of the equal sign, you just multiply that by 8t. And then you figure out what these three things are equal to here, these three circles. In the first one here, again, no factoring is needed here in order to cancel because everything's just a single term, all four parts of this thing that we're multiplying, the two numerators and the two denominators are all single terms, so you can just cancel right away. You should be able to get 1 times 1 on the bottom here after you cancel, and you see we do here. And so what do we have here? We got 1t times 5. That's 5t, isn't it? And then 1 times 1 on the bottom means you have no fraction because the bottom is 1. Bring down the plus again, just like in the last problem. The 8's cancel this time, so we have 1 times... oh, I'm sorry. I wrote that down wrong. Let's fix that. That should say 5 over t right there. You can see right there I just wrote down 5/8 again by accident. So instead of canceling the 8, I cancel the t, right? It's the t's that cancel. And so what I'm left with is 8 times 1, which is 8 here. But then 8 times 5 is 40. So figure out what your numerator is here. It's 8 times 1 equal to 8 before you multiply it by the other numerator. Okay. 8t times 1 is 8t. Okay. And then we have ourselves a normal equation, just like in the last problem after we figured out what those three things that I circled are equal to. So then I do what? I need to move the... Actually, I'm writing something I don't need to write again there. Okay, I already have it written down. I need to move over the 5t with the 8t. And so that gets the 40 by itself, but it also moves the variable terms over to the other side. And then I divide out to get the t by itself. So t is equal to 40 thirds. But as I mentioned in the directions there, when I wrote in the directions, that is, write it in terms of a mixed number. It's just easier to understand. Like I said in the last problem, it's easier to say to somebody, we're going to get the car tuned up in 1 1/5 hours. It's easier to say that than to say, we're going to get the car tuned up in 6/5 hours. There's a better chance they'll understand the basic amount of time that you need to get the car tuned up. So mixed numbers are better when you're talking about time, okay? And that's why we're doing that. So if it's not already a whole number, like if it had just been 1 hour, just one, not a fraction, then you don't need a mixed number. But if it's a fraction, it's better to do a mixed number. And again, I'm just explaining why we're doing that. What is 40 thirds if you make that into a mixed number? 3 going into 4 one time. 1 times 3 is 3. Subtract, you got the 1, but then you still got to bring down that 0 right there. 3 goes into 10 3 times. Okay. 3 times 3 is 9. And we have a remainder. Sorry, I'm kind of running out of space here. The remainder is 1. 10 minus 9 is 1. And so we end up with 13. And then the remainder always goes on top of that fraction of the mixed number. And then the number on the outside goes all on the bottom. So we end up with 13 1/3. 13 1/3. 13 1/3 what? Again, because it's time, and since time is measured in hours in this problem, 13 1/3 hours. That's how long it will take Betty to paint the front of the house working by herself. Okay. Please try this last problem here. It's actually very similar to the first problem that we did on the first page. The reason why that's true is because the question is what? How long will it take them if they what? Work together. Okay, so we're back to the work together question again, just like number one. So please give that a shot. It's, again, very similar to the first one. Let's see how that turns out after you hit the play button, and then we'll wrap things up here. Okay, let's take a look at number 3 here. Leia can groom the horses in her boarding stable in 5 hours. Tran can do it in 4. How long will it take them to groom those horses working together? So again, time working together is T. So we have these pieces of information here in the boxes. Let's talk about that. Since Leia is 5 hours by herself, it's 1 over T. I'm sorry, 1 over 5. Because our alone time is 5. Tran is 4, and therefore that's his alone time, and so his rate of work is 1 over 4. The time working together is T this time, not 5 like it was in the last problem. It's the variable this time, so we put that here. Again, both of these boxes are the same. We then multiply across in order to fill in these boxes for the same reason as before. We don't have any other way of filling in those two boxes for the same reasons as before. We then realize that since this is a problem where two people are working together with this setup here, RT equal to FP, that the way that we set up our equation that we need is to have the last two boxes in the last column add up to 1. And that's where I get this equation right here. T over 5 plus T over 4 equal to 1. Now the LCD for 5 and 4 is going to be 20 because that's the lowest common multiple of 5 and 4. Okay. Again, as a reminder, all right, you can see here as I'm writing this out that the lowest, and this is how you do it when your denominators just have a single term. They're not like the bigger denominators with more than one term. For the coefficients, you just figure out the lowest common multiple this way. And if there's variables, then we talked about that before, where you just take the largest exponent of that variable that you see. But again, it's not going to get that detailed in these in this particular worksheet anyway. It's either just going to be two constant denominators and then you just do this, or like I said before, if it's just a constant and then just a variable, you just have to do this. Okay, so that's just for this section here. If you see fraction equations, again, as you study for the final, for example, you need to go back and look at how to do all the different kinds of fraction equations that I asked you to study anyway for the final. But here in this worksheet, it's a little bit simpler, as I just said. Okay, so don't worry. So you can see that 20 is the LCD. We then multiply both sides of the equation by 20 in the same way we did the previous two problems, where you multiply the 20 by each of these two fractions, bringing down the plus in between here. The 1 gets multiplied by the 20. And then we figure out what these three circles are equal to. 20 and 5 cancel to become 4 and 1. Divide them both by 5, and that's why it's 4 and 1. 4 times t. Okay. This one, why is it equal to 5t? It's because 20 and 4 cancel, and we get 5 and 1. 5 and 1. Okay. And so that means 5 times t equal to 5t. And finally, 20 times 1 is 20. We then wrap it up here by solving that equation. Combine like terms, we get 9t. Divide out to get the t by itself. And I wrote down this additional decimal possibility, but as I said in the directions, just do the mixed number and you'll be fine. You can see here that I did the mixed number conversion right here. 9 goes into 22 times. 9 times 2 is 18. And so then we do 2 and 2/9. Again, the number on the outside always goes on the bottom here. And so 2 and 2/9. Why is it hours again? It's because they asked for time. Okay, the variable represents time. That question represents time. Okay, and so since time is measured in hours in this problem, that's why it's 2 2/9 hours. And so that concludes our discussion on work. Okay, and since this is the last video and you're starting to think about the final exam, I'm sure, as you should be, please let me know if you have any questions, not just about this, but about anything. Remember, you can contact me through sending me an email, a message, okay, or you can also visit me in my office hours as usual. Okay, the syllabus explains how to contact me during my office hours. Okay, and of course you can also message me if you have any questions about the office hours as well. All right, so let me know if you have any questions, and otherwise have a good day, and take care, and study hard, okay, as you prepare for the final exam. And also let me know if you have any questions about how to prepare for the final exam. I did send out a message about that. You may or may not have you should have gotten it by now. If not, you will be soon, but look out for that, about how to study for the final. And of course, let me know if you have any questions about that. Okay, so take care and have a good day.